Welcome to 7.5. Let's graph some parabolas. Okay, so I wrote some key concepts we need to know. We will use the quadratic formula, not for all of them, but for some of them. Our y-intercept, that's just our c. This we will rely on, our ABC from the quadratic equation. Whatever equation they give us, move it around and treat it as a, b, c like we've been doing in previous sections. Our x-intercepts, those are the values of x that satisfy our equation set to 0. When we set it for 0, solve for x, those are our x-intercepts. Our vertex is this formula. X equals negative b over 2a. Once you solve that, plug in the x, you find your y, and that's the vertex. The vertex is the high or low point of that parabola. Now, the x-intercepts give us 2 points to graph that parabola with if we are given x-intercepts. If we are not, we rely on that vertex, and then we choose an x value on each side. That allows us to graph it. So let's start with example 1. So because I wrote x-intercepts first in the notes, we will solve for x-intercepts first. We set equal to 0, and then we factor out. And I'll show you what's going to happen over here on this one. So set it equal to 0. I need a positive 5, so I need both the same, and I have a negative middle term. That tells me I'm going to have two negatives. So I just use 5 and 1. Doesn't matter. It doesn't matter what order you go in. So I know that my x-intercepts are 5 and 1. What does that tell me? Well, that tells me that the parabola crosses the x-intercept here and here. I have 2 points. I don't have to know anything about this parabola in order to do that. All I have to do is solve the equation and plot my two x values. Those are my intercepts. Now, the vertex, for the vertex, we use our A, B, C. The key is always remembering that this whole value is our B. That whole value is our C, and whatever here is our A. So we have a negative B, so we have a negative 6. My B is negative 6. That's all over 2 times A. A is 1. Some students like to say 0 when there's nothing there, but there's 1x squared. You just don't have to write the x. You're just saying, well, there's one of them. So I have an A of 1. So when I work this out, I have positive 6 over 2 equals 3. That's my x value. I know my x is 3, but I don't know if it's up here, down here, so I need to solve that. So I take my y equals, I take my original equation, go back to the original equation, and now I have solved x. My x is 3. So now I have 3 squared minus 6 times 3 plus 5. So I have 9 minus 18 plus 5. Well, that's negative 9 plus 5 is negative 4. There's my point. My vertex is 3, negative 4. Now that tells me I go to 3 and then I go down 1, 2, 3, 4 on the y-axis. And that point there, although my graph is not the greatest, that's our bottom point. That shows us we have a parabola opening upward and crossing the x-axis at 5 and 1. So you take your equation and solve it, and you get your x-intercepts, and then you just use this simple formula to get x, plug that in, and you have a vertex and you've graphed a parabola. There's really nothing to it for the simpler examples like this. We're going to do 2 more examples that have their own unique features to give you a better feel for parabolas. So example 2 is what we're going to move to, and we have y equals negative x squared minus, there's my 2, minus 2x plus 3. Okay, so to solve it, to set it equal to 0, I'm going to negate so that I have positive. This is my original equation. but to solve it, I'm just going to negate it to set it equal to 0. So I have a positive x squared plus 2x minus 3. Now I can solve, I can factor out positive x's. And then I have a negative 3, positive 2. So I need a positive 3 and a negative 1 to give me my negative 3 with a positive 2x in the middle. My x-intercepts are negative 3 and 1. So maybe I will, maybe I'll graph just this one here. I'll graph this one real quickly, just for one added little piece for you to see, one added visual. So my x is negative 3. 1, 2, 3. So I know I'm crossing there, and it's 1, which is there. So now all I need is my vertex. And my vertex is a negative b. I go back to the original. My original equation holds my actual a, b, and c. So a negative 2, negative b, so a negative negative 2, all over 2 times a. My a is a negative 1. So what I end, whoops, I don't know why I said 4. What I end up with is a positive 2 over a negative 2 equals negative 1. That's small. You probably can't even see it on there. Hopefully the autofocus is doing okay. I might switch back to manual for the next one. Whoops. So for my vertex, I'll do this differently so you can follow along. My vertex, my x value, is negative 1. So I just take my original equation, and I have a negative 1 squared minus 2 times negative 1 plus 3. That gives me negative 1 squared is 1, but I have a negative 1 squared. And then a positive 2, positive 3. So it's 4. So my vertex is negative 1, 4. So I go over negative 1 and up 1, 2, 3, 4. When you're solving the vertex, the formula gives you x. You plug that x in to solve for y. So that's my vertex point, negative 1, 4. So I go up to 4, and I can see this parabola opening downward now. Okay. Let's do one more before we move to section 6. We'll do example 3. Example 3 says graph y equals 3x squared minus 6x plus 1. So, for this one, we need to rely on the quadratic formula to find our x-intercepts. We can't factor this neatly, so we will use our quadratic formula, which says we need a negative b. Our b is negative 6. So a negative 6 plus or minus the square root of our b squared, negative 6 squared. I'll write everything out so that you can see where they fall. Minus 4 times a, which is 3, times c, which is 1. And that is all over 2a, which in this case is 3. So to clean it up a little bit, I'll just move over here. It's negative 6, so that's 6. Plus or minus square root of 36 minus 4 times 3 times 1 is 12 all over 6 equals 6. Plus or minus square root of 24 over 6. So we're going to keep going with this one. I'm going to erase before I find the vertex. So we take our 6 plus or minus square root of, and instead of 24, I need to break that down. I need to see what I have. Well, 8 and 3 don't do me any good because I'm working with a square root. but 6 and 4 help me out quite a bit, because now I can turn this into 6 plus or minus 2 square root of 6 all over 6. And again, what I could do here is I'm just going to say that's 6 over 6 plus or minus 2 square root of 6 over 6 equals 1, because my 6's divide, plus or minus, because I'm pretty sure the book wants you to break it all the way down. My 2 and 6 are divisible by 2. 2 goes into itself once, 2 goes into 6 3 times. There are my x-intercepts. Those are nasty. I'm not going to graph that by hand. Can't just plug something in real quick, but I have them. I know I have some x values there. Whoops, I don't know why I'm doing that. I know I have some x values there, but I don't know how to graph that by hand real quick and easy. So I'm going to solve my vertex. So, oh, that's why I grabbed it, because I erased the whole thing. So now, in this case, I have a negative b, and my b was negative 6. And then I have 2a, and my a was 3. So I'm going to solve the x of my vertex. So my x is a positive 6 over 6 equals 1. So I plug that in. I had 3 times x squared minus 6 times x, and then I believe it was plus 1. Yeah, my c was 1. So let me figure this all out. I have 3 times 1, whoops, and I have a negative 6 times 1 plus 1. So I have negative 3 plus 1 equals negative 2. So my vertex is 1, negative 2. I don't think I had anything. Nope. This is all I wanted to do. 1, 2, and 3, because those were the examples that showed quite different concepts. The first 2 we could easily graph. This one we couldn't easily graph. You plug it into the graphing calculator for sure, but you at least can find the vertex. When you get something nasty like this, you know there's x-intercepts. So go ahead and plot the vertex, and then choose an x value on each side of it, and you'll be able to graph that parabola. So, all right, I'll be back for section 7.6, and we'll be done with chapter 7. See you in a bit.